Hi everyone, welcome back to the session. So today's we are having a new topic with us. Means when it comes to the data, you can't rely on a single system to work upon. Ultimately, you do have some third party APIs. You actually rent them from other parties. So what you have to do, you have to integrate those APIs, and it's not so easy to work with when it comes to integration of different types of APIs with even if you're renting them from others. So when it comes to data, as I always talk about, Spark is one of the best tool when you talk about the data, the pipelining, which you should work upon. So in this session, I'm expecting that I will be learning a number of things about the Spark structured API along with the DataBricks, means how the DataBricks APIs can be integrated with the Spark one and different types of properties, inheritance, means everything. I'm just very curious to learn about all those things. So hi everyone, welcome to this session, and I'm just welcoming our today's coach, our today's mentor, Ravianshu Singh. He's a software consultant in Noldes INC. So Ravianshu, the stage is all yours. Please start the session.
Yeah, thank you, Kuldeepa, for such a wonderful introduction. So, hello everyone, welcome to the knowledge section, which is in this session we will be covering the Spark structured APIs using the DataBricks platform. So, let's get started. So, first of all, as we all know, we have some of the knowledge etiquettes in our knowledge, which we follow during our knowledge session. Starting with punctuality, so you all are required to join session 5 minutes prior to the session so that we could conclude our session on time. Second one is keep your electronic device in silent mode, but you are feel free to move out in any case of emergency call or an emergency meeting. Please avoid any sorts of chit chat around you so that you could concentrate fully on this session. And the last but the most important is the feedback. Please make sure that you submit a constructive feedback as it helps me as a presenter to improve my knowledge skills. So moving on with our agenda. So what we have in our platter today. So today we will be starting with what is Spark. So how is Spark different from Hadoop? What is its ecosystem? What was the architecture of this Spark? Then we will be moving towards the how Spark introduces three APIs, RDD, data frames, and data sets. A bit of introduction in that too. Then we will be covering each APIs in detail, starting with RDD. What's an RDD? How is it constructed? What are the problems associated with RDDs? After that, we will be looking towards the solution. That what was the solution which Spark gives to handle the problems which were having in the RDDs, and then we will go covering the data frames, data sets, and after that we will be going through the DataBricks, which is a lakehouse platform, and at the last I will be concluding my session with a demo. So starting with what is Spark. So Spark is a unified analytics engine. So what we mean by that? So Apache Spark is a unified design for large-scale distributed data processing on premises in data center or in cloud. So Spark provides in-memory computation, which makes it much faster than Hadoop MapReduce. So not only that, it also comprises libraries such as libraries for machine learning like MLib, for Spark SQL, for SQL interaction like Spark SQL, and many more. So, if you look into the Spark's design philosophy, it revolves around four key categories, which is starting with speed. So the key factor which gives Spark speed is its direct acyclic graph, commonly known as DAG scheduler, and query optimizer, which builds an efficient computational graph, and that consists of tasks which can be executed parallelly across the workers on the cluster. Second one is ease of use. So Spark consists of simple logical data structure known as RDD, upon which all our high-level data structures, which are data frames and data sets, are constructed. So and that we will be covering in our upcoming slides as well. And modularity. So what gives Spark the modularity? So Spark operations can be expressed in any supported language. It could be Scala, Java, or R. And last one is extensibility. So unlike Hadoop, which include both storage and compute, in which we have to as we know, Hadoop contains both the storage as well as its compute function known as MapReduce. So Spark decouples that. You can use any databases in order to fetch your data. It could be Redis, it could be Data Lake, it could be Apache Hive, etc., and process it all in memory, which makes Spark faster than Hadoop, like in memory computation. So moving ahead, and also one more thing, Spark follows the master-slave architecture in which your Spark driver is your master and your workers are your executors, and your executors are your workers. Sorry. Yeah. And moving ahead, yeah. So let's move into Spark's timeline and see like how Sparks introduced their APIs. So starting with, in the initial release, Spark introduced the RDD, which was released in 2011. So it consists of features like distributed collections of JVM objects, function operators like we have in Scala, the map filter, and etc. So moving ahead, on 2013, Spark introduced another API, which was DataFrame, and it consists of structuring, like which we will be covered. So in which my whole presentation is based on structuring. So Spark introduced structuring with DataFrame in 2013, and it has properties like distributed collections of raw object, expressing based operation and user-defined function. It was fast, efficient, and has internal representation. And the last one which Spark introduced, so which is dataset in 2015. So dataset comprises the combination of both the RDD and the data frame. So that's why it can be represented internally as a row, and externally we see it as a JVM object. So it was a combination of best of both worlds. It was type safe, and it was fast. So moving ahead, so let's look into all three APIs in details. So what's an RDD? So RDD represents an immutable partition collection records that can be operated on in parallel. So at the core, RDD is an immutable distributed collection of elements, which is your data that is partitioned across your nodes in your cluster, which can be operated in parallel. Also, RDD gives you complete control because every record in RDD is just a Java Python object. You can do map, filter, anything on it, and it's your wish how you want to optimize it, how you want to do the computation on it. It's your wish. So with RDD, there are three vital characteristics which are associated with it, which are dependencies, partitions, and compute function. Let's look into them one by one. So starting with dependencies. So dependencies are the list of instruction that instruct Sparks how an RDD is constructed. So if Spark, another one is that Spark can recreate an RDD from these dependencies and replicate operation on them. So what we mean by this? So suppose if one of if suppose if one of your executors got failed and driver had to reproduce the results in case of the failure of the cluster. So what Spark will do, Spark will take these dependencies and it will replicate the operation on them which you did already, and it will give you the result. So this gives RDD characteristics known as resiliency. So that's right. That's where the word R specifies in RDD, which is resiliency. Second one is partition. So partition provides Spark driver the ability to split the work across executors so that a computation can be done quickly. And also, Spark uses locality information to send the works to executor across this data. So this helps. So this helps in way that less data is transmitted over the network. So if your Spark driver knows like what is location of your executor, Spark can transmit data quickly, which is very efficient. So this distribution of data across the executors give RDD the distributed characteristics. So that's what D defined as, and D and the last one D is the data set. And the third characteristics which is measured in RDD is its compute function. An abstract compute function, it's an abstract method which is which works internally. It produces an iterator T for the data that will be stored in an RDD. So it takes a split partition and context which is defined, and it produces an iterator T. So we will be covering more about this compute function if in next slide. So moving ahead. So if you visualize an RDD, so like how you can construct an RDD. So starting with, so suppose I have a data stored which is a text file only. It's a Gettysburg address image, a famous words written by the famous Abraham Lincoln, the greatest Abraham Lincoln. So I have stored in, so this is a location where this is residing. So suppose I want to read this file. So what I will do, I will use the SC. SC stands for the Spark context. So Spark context is simply the entry point of the Spark application. So whenever the Spark code runs, it look for this Spark context as the entry points. And after it, we are using the function text file because it's a text format. And one more thing, this text file will only executed then, or it will be lazily evaluated, which means that whenever we will be calling this RDD, then only this will get executed. After that, so suppose we want to we want to count the number of words inside this inside it Gettysburg address text. So let's do some transformation and operations and actions on them. So what we did, first of all, we filter out everything which we do not require, like the hyphen, commas, and the spaces which are unwanted for us. So we remove that part. After that, we use a simple fat map in order to construct the words into an array. After that, we use the map in order to construct a tuple with the word and the and the number of count associated with it. Then we use a reduce by key function. This is an internal function which RDD has. So what it does, it has the key and value as an input, and it aggregates the value based on the key we provided. So that's it, and that's a functional way of representing it. And then we simply ordered it by its value, and then we did the correct, and then we printed it. So you see that all of our words with number of counts in the ascending order has been arranged. We will look into it more into our demo session at how this is working. So this implementation is quite simple and elegant, but yet there is a problem associated with it. And what are the problems that are associated with it? So starting with the first problem. So all this function which you are performing, the map, flat map, reduce by key, these all, so what are these? This is a computation function which I talked about in the previous slide, that this compute function. So this is what I meant by the compute function. All your flat map, reduce, sort by, these all are compute function. So this compute function is totally opaque to Spark driver. It doesn't know like what it is. It just considered it as a JVM object. So which gives no optimization by Spark. So there is no optimization which can be done by the Spark or on your RDD. So suppose you have the big data set, so you have to manually optimize it. So that's the biggest problem associated with it. And it's slow for the non-JVM languages like Python as well. So and since the compute function is opaque to Spark, there are no compression techniques on your data. Your data will be residing and consuming the same amount of storage as it should be, as it has it. And so all these leads to inadvertent efficiency, the efficiency which we should not be worried about, but still but they can cause a major problem if you have the huge loads of data. So what's the solution for it? The solution comes in the structuring of data, in the structuring of the APIs actually. So let's move it. The solution is in structuring. So, and what we meant by structuring. So structuring is nothing, just ordering and structuring for allowing you to arrange your data into the tabular format. So this is so as you have seen in your relational databases, you have your structured data. You can represent your data into a tabular format, which is very easy to read, easy to visualize, easy to maintain. So that is the very cherry on top for our developers, and we can visualize the data. So that was introduced with the that is what introduced with the structuring. And the second one is the expressing the computation using patterns like filtering, selecting, and counting. So all those features which are in SQL, so which all these features which we use in SQL, that got introduced with the DataFrame. So all this simplicity, that we developer cherish for, like we can use just simple filtering, and we can filter out our columns. We can just do simple select. We can select our column. So all this simplicity that we developer cherish is possibly because of this Spark SQL engine over here. So upon which all are, so what we do, we simply write our queries, our code inside this Spark SQL engine, and it handles everything. It handles everything. So upon top of which all our high level APIs are constructed, namely Spark SQL, DataFrame dataset, Spark streaming, machine learning, and graph processing. And so that's the major important of the Spark SQL engine. So moving with the so that's what that was what we meant by structuring actually. So now this structuring is implemented in the DataFrame API. So DataFrame API is just a distributed in-memory tables with named columns and schema, and where each column has a specific data type, and it could be string, int, timestamp, and etc. So that is what DataFrame API is. So if we move ahead and visualize the DataFrame API, so suppose we have a raw data and it contains the ID, first name, last name, URL. So suppose you all publish blogs. So this is like a link to you to your blogs. Consider that this is the date in which it was published on, and this is the number of hits you got in your blog, and these were the social sites in which your blogs were campaigned. So suppose if we want to construct this data into a data frame, so simply what we have to do, we have to use this data. We have and in that we will be using a 2df function, which is an inbuilt in Spark, and then we can specify the columns, and then we can simply apply the show action, and which will result in this output. So see, all our data is structured in viewable manner, in tabular manner. So that's what data frames is. So if you look into some of the operation which Spark generally have before moving into the Spark the data frame operation, this is important thing to understand. So Spark operation can be classified into two, the transformation and action. So what transformation is? Transformation is simply transforming a Spark data frame into a new data frame without altering the data. So which gives so whenever you are trying to do transformation, it will gives you immutability because you are not altering the data. And another one is action. So action are the operations that returns the raw value from your data frame. So suppose you want to do the number of counts in your data frame. So how many counts are there? So you will just do .count method, and it will return you the number of counts in that data frame. And one more important thing. So this action triggers a lazy evaluation of all the recorded transformation. So all the transformation which you have already done in your data frame, Spark will lazily evaluate those whenever you perform an action, and it will gives you the result. So some of the common transformation are order by, group by, filter, select, and similarly we have actions like show, take, count, and collect. So moving ahead now we know what's the Spark operation are. Now we can see what operations we can apply on our data frame. So first one is projection and filter. So simple. Projection is a way to return only the rows matching a certain relation condition by using a filter. So like we do filter in our data sets. Using filter method in Scala, the same way we can do it in data frame as well. So projection are done with select method, and while filters can be expressed using the filter or where method. This is important. So let's take an example. So suppose we have a data frame and we selected its ID first and URL, and we want to organize on the basis of, and we want to get the data on the basis of hits, like how many how many were the blocks which has the hits greater than 10,000. So we simply specify the dot where, or we can specify dot filter and mention a condition which is hits greater than 10,000, and we will get our results if we do the show on that. And second one is renaming, adding, and dropping columns. So using with column rename, we can rename a specific column. So if suppose you are doing some computation and there's a need to rename that column in order to match the schema, in order to perform the join or other things, you can simply do that by using the with column rename method. And also, if you want to add some new column to your data frame, you can also do that using the with column method and add a new column. While that, and simply last one is the drop, in which you specify the column name which you want to drop, and it will drop it inside the drop. So in this example, so suppose I want to add a new column naming issue date, and I also want to assign I want to assign it a data type which is a 2 timestamp. And so how will I do that? So simply, so first of all, let's look into the with column rename. So suppose I want to change the name of the first to first name. So simply I will take first to first name, and it will rename it. Simply I can do it with the last as well. So now suppose if I want to add a new column, I will just write utf.with column issue date. Then I will specify the data type of that, and I am changing the data type of published column, which was string, to 2 timestamp column. And also I'm specifying the format in which I want my timestamp to look like, which is day, month, and year. And after that, I'm dropping the published column because I no longer require that particular column. So if you see, the published column will be there with the change of first name and the last name. Okay, so moving ahead. So there is one more most important operation on data frames known as aggregation. So transformation and action on data frames such as group by, order by, and count offer the ability to aggregate by column names and then aggregate the counts across them. So this is the most important operation on data frame which we can do, because this gives us the answers to our results. So suppose we want to see how many how many campaigns were done in the collective web, Twitter and Facebook. So this so combining all these aggregation, we can get our answer. So suppose we selected our campaigns and first name, and we and you know, in order to not get any null value, we just mentioned one filter condition over here, projection and filter, as you remember in the earlier we have discussed this. And after that we did the group by campaign, because we need the data from the campaign, like where the blogs were shared the most. And after that we did a count, and then we simply did the order by in the descending order, and we get all our campaigns in the descending order and like where they were shared. So this is the most important aggregation which we use in getting the answers to our from our data. So moving ahead. So now we have covered the DataFrame API. Let's look into the datasets API, which is the combination of both RDD and the DataFrame. So a dataset, the dataset API, a type safe one. So what I mean by that, so let's look into the definition which dataset documentation provides to us, which is specified as a strongly typed collection of domain-specific objects that can be transformed in parallel using functional or relational operation. Each dataset in Scala also had an untyped view called a data frame, which is a dataset of row. So see, it's a combination of both. It's a combination of untyped object as well as the data frame. So that's what that earlier I said that dataset is a combination of both RDDs and data frame. So conceptually, think of data frame as in Scala as an alias for collection of generic object, and dataset row where row is a generic type of JVM object simply. So if you look into the data frame and dataset, they both are structured API, and the untyped API in which we don't specify any data type like what's associated with it. So that is data frame. It just has a collection of generic object, a data set with a collection of generic object, and in type API we specify this type of like what our data set look like. And since it deals with the type, so it can't be applied to the Python or R's, because both are dynamically typed language. So this can only be applied in Java or Scala language. So if you want to visualize a data set, so suppose we have IoT device data from various location, and we constructed a case class, so in which we have the device ID, device name, IP, and all other things. And after that, so we have constructed a kind of a schema in here with the help of a case class, which will give the type safety to our data set. And after that, we read the JSON from our desired location, and after that, we pass this this case class as using the function as, and then we specified it, and after that if we do the show on that, which is an action, and this is this 5 comma false over here means the 5 number of rows we want to see, and if we want to see a truncated result or not. Since we are doing 5, we can do false or true as well. So you see, that's how our data looks like through this set of data, IoT device JSON. So if you look into some, so data sets, so we can do the same operation as I discussed in the data frame in data sets as well. All the projection filters with column rename, with column, adding a new column, dropping the column, or if you want to do aggregation using the count or aggregate function, we can do same in data sets as well. So moving ahead, so yeah. So yeah, let's talk about the DataBricks. So what is DataBricks? So DataBricks is kind of a cloud platform. You consider a cloud platform, a lakehouse company. So DataBricks lakehouse platform provides a unified set of tools for building, deploying, sharing, and maintaining enterprise-grade data solution at scale. So the database is a cloud platform that is built on either in your Microsoft Azure, AWS, or Google Cloud, and through that you can do either data warehousing, data engineering, data streaming, or data science and ML. And what are the core features which DataBricks offer to you? So it has interactive notebooks, just like you have the Jupyter notebook, but it is more interactive than the Jupyter. It has more functionality than the Jupyter notebooks. It gives you workflow scheduler. If you have scheduled some of the notebooks that you want to run in specific interval of time, you can do that using the scheduler. Then you can do SQL editor. You can simply specify percentage SQL, and you can directly execute your SQL query through it. And even it provides the dashboard in order to visualize your SQL operations. And it provides the data ingestion, compute management. You can specify which cluster you want to use, what node type which you want to use. You can all do that using the compute management. And then you can also integrate it with the Git. You can do Git source controlling as well. You can do machine learning model in that, and you can visualize that machine learning model through that also. And also you can use REST API to control your database, as well as the database CLI as well. Okay, so let's give you a walkthrough like how our database looks. So I will be using the community edition of the database. So this is how this is what the community edition of database looks like. It has interactive notebooks, your data import, AutoML, guide to dashboard tutorials, transform data, and other things as well. And after that you have this sidebar where, so since I'm in the community edition, I can't look into this workflow, because it will tell me that you need to update your database or other things. But if I show you the DataBricks community edition, not this one, a paid DataBricks. So this one is the paid database, and if I show you this, so it has features like you can schedule your workflows in here. You can create your workflows in here, and you can schedule it. You can do Git source controlling it. You can do compute management over here. So all are features which we have in our database. You can specify which cluster you want to use. So and also you can create a new cluster inside your database. You can select if there are some policies which are already predefined for you, you can select from here. But if you want to construct your own cluster, you can simply do that by that. You can select which node type you want to use. So see, there are so many node types, and and each node type has its own features, and these all node types are the EC2. So since this database is constructed over the AWS, all these node types are the EC2 instances actually. And you can specify the what will be the minimum worker of node, what is the maximum number of, if you are auto scaling it. If you don't want to auto scale it, you can simply turn it off. And similarly, if so this is an also in DataBricks we have two types of cluster actually, all purpose and the job clusters. Job clusters are associated with your workflows, and they will get terminated as soon as your job failed or gets completed. But the all purpose cluster, in which I am currently, it will get terminated by the amount of time specified by you. If you unchecked it, it will remain running, but it's good practice to terminate after a required number of seconds. And after that, there are advanced options in this, in which you can do on demand, spot, like how many cluster you want in on demand, and if you want to use it to fall back. So a combination of both result in the efficient cluster creating. That's another topic which can be covered in entire new knowledge section. So after that, we can specify the init script. This init script is important. If you want to include some extra functionality in your database, you can specify that. And if you want to specify any of the Spark configuration, then you can do that. So that's how simply we can create the cluster. You can specify the data if you have any of the, you can import the tables, anything you can you can do with that. Also, as I told you, in database we have the Git source controlling as well. You can you can select any of the branches you want to select from it. So these are all the functionality which DataBricks offers to us. So if you move back to the community edition and look into the notebooks, so not demo. Yep, got it. So this was the text file which I was talking about earlier, like a famous text by Abraham Lincoln. So if we just simply head it, we can see it contains all this paragraph. And suppose if you want to read, if you do the word count on this paragraph, so that's we can do it. We can simply doing the Spark context of text file, then we are reading this text file, then we are performing the the different JVM objects, as we know as in RDD they are called as, because Spark doesn't know what is map, flat map, and this map, flat map, and reduce by key. So that's what I mean by reduce by key. It's take actually key and value pair, and it returns the aggregation based on your key. So if you run it, hope my cluster is running. Yeah, my cluster is running. I can check my cluster from here as well. I have two cluster running. That's interesting. So if I run it, I will see the each words count in according to the ascending order. So like 4 got one time, and this is a simple word count problem. So, and there is another thing. So there is another advantage of DataBricks. As you can see, this is a Scala notebook, but I can simply specify dot %py, and I can do the coding in Python as well. Similarly, I can, so this is a Scala, by default it's a Scala notebook, but also I can do like percentile SQL, and I can run the SQL query in there. See, it changes to SQL over here. So that's the major advantage of the database we have. So let's take another example of the RDD. Suppose we have this data set and we want to calculate the average of all these people having having the same name, and what are the what's the average of their age. So using RDD, so see how clunkier process if we do it with the RDD. So in Python also we have similar map as we have in Scala. Just the syntax is a bit different. So we simply calculated the average of all these people, and if you run this, we will get in tabular form. We will get in tuple format actually, in list format actually, a tuple collection of list. So in Python, the list can be specified by via the square brackets. So but not the same process. If you look into the using the data frame, see how simple it is. We just specify the group by, if we want to group by name, and then we aggregate them, and then we simply did the average function. We just imported the average from the PySpark.sql function, and if we run it, see how simple it is. Writing this much of code or writing just an average function, we simply got an answer, which is the name and their average. So that's how simple it is. So let's quickly go into the demo session, which I want to show you, because I have approximately 10 minutes left. So yeah, so suppose there is a fire department in San Francisco, and you got the collection of data in the CSV file, and the CSV file will contain almost 4 million of rows. So if I could show you, this will show me the truncated data, because it's very huge. See, it's showing the truncated to first this number of bytes, because it can't like show the 4 million rows over here. So suppose we want to answer some of the questions like what we wanted to see, like this zip code, like which area accounted for most common call for the fire call. So as since we have this area column over here, we can do that using Spark, and that is very simple using the data frame. So here is where my this data is locating, since I've shown you using the head as well. And if you run it, these are some of the imports that we have to do. I don't require this. This doesn't require, yeah. And one more thing, since this data contains 4 million rows, it's so inferring schema is the bad idea if you are dealing with such huge amount of data set. So whenever you have the huge amount of data set, construct your own schema. This is much more efficient than inferring the schema, because that's the most expensive process if you're inferring schema from the data set as well only. So I have specified the column names. So these are all our column names and their types. And if you can just run it. Yeah, after that, I am, so since I'm constructing a data frame over here. So so there is, so you can construct data frame by any, like there are a number of ways you can construct your database. Earlier we used the 2DF method. We can also use, so since it's a so since we are reading the data from a specific place, we are specifying dot load method, because this is where I've stored my this data. So after that, if so, I just did the spark.read.format in CSV format, option header true, and just load it and displaying only uh, the 10 rows of our data. So this is what our data looks like. So yeah, let's do some operation in it. So let's do some ETL operation in it. This is in Scala, and so let's create a data frame first. Well, df equals to fire. So we will use this particular df, fire df, and then we perform the operation on it. Then suppose we want to rename some of the columns inside it. We did with column rename. Column rename, and let's use that particular column. So suppose we want to rename the column delay, and with the name the response delay time. So let's change the delay column name. Where is the delay column name? Yeah, so here's a delay column. Let's change it to response delay time. Response delay time, and then we can simply do df dot yeah. So if we go into, so let's see, this was a column name delay, and I've renamed it to response delay time, and it has changed successfully. After that, let's do some column add some column over here. So if you want to add some column, we can simply do where create another data frame where station fire station df, which will take df dot with column, and just specify the new column which we want to add, incident date, and specify the what's the data type we want over here. We can just specify the timestamp and specify the column which we want to take the data type, which is called date, I guess. I'm not wrong. All date. Yep, all date. Sorry. All date, and specify the type I want to introduce in there. How is the format will look like? So month, simply day, and year, and simply then after that we can drop our call date column. Yeah, and if we, I hope I've done it right. Yep, done it right. And if we display our fire station df, simply can do that, specify some limit. Let's leave it to 10, and hope so. This will give us the new column name, naming the incident date. Where it is. Oh, there are so many columns. Yeah, see, it's added the new column incident date with the timestamp. So these are all are the different types of operations which we can do in DataFrame. There are much more operations as well, like aggregation and other things. But since we are since we are running low on time, I won't be able to show you. But in other knowledge sessions, I will for sure I will be covering them. And so yeah, so that was my knowledge section. So if you guys have any question, I can quickly take that.
Guys, I would encourage and appreciate if you can ask any of the question. If you do have, we will be happy to answer you. We have our coach Ravi Anshu who will answer you in the perfect way, which you will get your answer. So if you do have any question, please.
Well,
Priyanshu seems here good to go.
okay. So yeah, guys, and one more thing, guys, please do share the constructive feedback. This is very important for me. Yeah, I request you, please.
Okay, so thanks Ravi for this wonderful session, and there is a number of takeaways from what I had learned from this session. Means what actually is the Spark, the data sets, data frames, and at last the wonderful things which you have taught us, which is the DataBricks, what actually it is, and how to actually work on this. Because very honestly, before this, I was just new to the means I was very not exactly known to that topic, but today the way you taught us is pretty appreciable, and definitely I will try to have a good hands-on on this topic, and will get back to you if I do have any doubts. So I ask
Yeah.
everyone, please go ahead, do practice. If you have do any question, reach out to us on GChat as well, and we will be happy to answer you. Thanks everyone. Thanks for the wonderful session. And please, there is a request to please share your constructive feedback, as it is very important for us in order to make our session more interactive, much better. So thanks everyone for the session.
Thank you, Ravi, for this wonderful
Thank,
session.
thanks everyone. Yeah.
Devanshu. It was a great session.